Hello everyone and welcome. We're going to be looking at the lesson 3.8 practice today. Not too long, got about 9 slides here. So on the first slide we have our lesson summary. Sorry, I just noticed my glasses were so dirty. Okay. So in the previous lesson we were talking about measures of center with mean and median. Now we're looking at the measure of spread, which is our standard deviation. It's telling us if the standard deviation is really big, it means the data is really spread out. If the standard deviation is really small, it means the data is really compact and together and close. So for these two dot plots, we can see dot plot A has a bigger standard deviation. And that makes sense, right? Because we can see that these dots are more spread out. They're going all the way from 2 to 8. Versus in dot plot B, they're just going from 5 to 7. They're much closer. That window is smaller. Excuse me. So the data in dot plot A has a greater standard deviation than the data in dot plot B because it's more spread out. Perfect. One way to calculate the standard deviation is using the Desmos graphing calculator. You find the function for standard dev p, and then you insert a list of data values in a bracket, and it will calculate the standard deviation for you. This is a really big thing to do by hand, so we're grateful to use the calculator for this method. Push ahead to slide 2. It wants us to find the mean and the standard deviation of each data set, and we're rounding to the nearest hundredth. So I'm going to open up my calculator, and to find the mean of this first data set, I'm going to add it all up. 14 plus 14 plus 15. 2 16s, 2 18s, and a 19. And we get 130. Now, oops, didn't want to do that. 130, and then we're going to take 130 and divide it by the number of data points that we have. So we have 1, 2, 3, 4, 5, 6, 7, 8. And our answer is 16.25. Beautiful. Now we're going to find the standard deviation of that. So I'm going to close that out, and we're going to hit funcs, scroll down to standard dev p, and then put a bracket, and list this data set. 14, 14, 15, 16, 16, 18, 18, 19, close it, and there we go. So we have 1.785. So we want to the nearest hundredth, so we want 2 decimal places. So we're wondering, does this stay in 8 or do we round it up to a 9? So since it is a 5, we round it up, so this is going to become 1.79. Beautiful. And let's close out and do the second one. So we have 2 plus 3 plus 6 plus 6 plus 8 plus 8 plus 10 plus 11 gets us 54. And we're dividing it by 1, 2, 3, 4, 5, 6, 7, 8 numbers. So we get 6.75 for the average. And then we find our function for standard deviation. P, where are you? There you are. And plug in this data set. 2, 3, 2 6s, 2 8s, a 10, and an 11. And then close the bracket. And we get 2.95 4, 7. So we want two decimal points. So we look at this 4, and we're wondering, do we keep it a 4 or do we round it up? So since it's a 7 after it, we're going to round it up to a 5. So we have 2.95. So make sure you have all of that plugged in. And when you're all set, push ahead to the next slide. Okay, Moon and Alejandro are both on the track team. Each day in May, they recorded the average distance that they threw the javelin. Based on the data, who is a more consistent thrower? So if it's a more consistent thrower, right, that means the data is grouped closely together, right? They're not doing 110 and then 140. They're doing javelin throws that are all really similar values. So if they're really similar, the standard deviation is going to be smaller. So for Alejandro, it is 1.2. So that's going to have a more consistent thrower since the standard deviation is smaller than 2.6. If a throw of 160 was added to each data set, whose standard deviation would change more? So this number 160 is pretty far from 128, right? And right now the standard deviation is pretty close. It's 1.2. So that is going to make Alejandro's data even more spread out. That 160 is going to really stretch the standard deviation. It will also stretch it for Moon, but just not as much because their data is already more spread out. So again, this is going to be Alejandro. Okay. And go to the next slide. Order the data sets from smallest to largest standard deviation. Use the calculator to help with your thinking. Okay. So with this one, you are going to open your calculator and hit Functions, Standard Deviation P, and type in the data set. For the first one, I get, well, here, let me type it in over here. The first data set is 2, 2, 5, 22, 25, 25, and you can see that's pretty spread out. When we typed in the calculator, we got 10.59. Standard deviation is 10.59. Pretty spread out because we have a 2 and then we have a 25. So that standard deviation looks pretty big. Let's look at the next one. Okay, we have 4, 8, 9, 10, 12, 13. These numbers feel closer together. It's going from 4 to 13. So notice that the standard deviation is smaller. It's 2.92. So for the next one, our standard deviation is 2.92? Yeah, much smaller than 10.59. So that one so far is going to be at the top. And then we'll look at the third one. 7, 10, 12, 14, 17, 19 gets us 4.06 rounded. 4.06. And that's for our data set of 7, 10, 12, 14, right? Yeah, 17, 19. So smallest to greatest, our smallest one starts with the 4. Then we're going to get our 7, 10, and then finally 2 to 25 is the largest. So make sure you're practicing that in your calculator as well, that you feel nice and comfortable looking at those values and plugging it in. And when you have it all arranged, go ahead to the next slide. Here are the high temperatures in Seattle for each day in 2021. If the data points for the hottest and the coldest day were removed, would the standard deviation increase, decrease, or stay the same? So it looks like the coldest day in Seattle is here, and the warmest day is here. They're not too far off from the rest of the days, but they are like the smallest and the biggest values. So right now, right, here's our current range. We're looking from this, wow, I cannot make a straight line through there, this point to this point. And if we get rid of those points, now we're going to be looking from this value to this value. So the data is going to become a little closer together. So the standard deviation is then decreased. It'll get a little smaller because our data will be a little closer together because we're getting rid of our smallest and biggest point. Not by a ton, but it will be a little bit smaller. Good. Next slide. Here's a data set. Select all of the changes that will make the standard deviation smaller. So we have 4, 5, 5, 6, 7, 9. If we bring this into our calculator, 4, 5, 5, 6, 7, 9. Right now our standard deviation is 1.63. And we want to see what's going to make the standard deviation smaller. So the first one is, what if we added 2 to the data set? Now, if we added 2, we're going to spread the data out more. So we can see it's definitely going to get bigger. Now it's 2.06. All right, that's not an answer. If we add a 6, it's not going to make it more spread out. Now we have 1.5. It's actually grouping more of them closer together around 6 and 5. So that's going to make it a little smaller. If we remove the 4, that's our minimum value. So if we remove the minimum, the numbers are going to get closer together. So now it's 1.49. We put the 4 back. Same thing if we remove the 9, we're getting rid of our maximum. So now it's 1.01. So that made it smaller. And increase each value by 10. So then it would be 14, 15, 15, 16, 17, 19. It's going to stay the same. We're not making it more or less spread out because we're adding the same amount to each data point. So we want to select those middle 3 there and then push ahead to the next slide. Here's a dot plot showing the weights of fish. Select the weight of fish that would change the standard deviation the most if I added it to the data set, and select the weight that would change it the least if I added it to the data set. So I want you to try this one out on your own. Feel free to use the calculator and figure out what the standard deviation is, right? We have all the points here with 3 1s, a 4, 4 5s, 2 7s, 3 7s, and 2 10s. That's our data set right here. So you can find the standard deviation and then see how it shifts with the fish if you want to use the calculator, or you can use your thinking to see what would shift it the most and the least. And then push ahead to the next slide. Looking at some more exponent reviews for the first one, if we have a 12 cubed then raised to the 5th power, this is power to a power, so we multiply these exponents. 3 times 5 is 15, so this would be a 12 to the 15th power. If we have 6 to the 4th divided by 6 to the 5th, remember we subtract these exponents. So this is 6 to the 4 minus 5, which is -1. And then finally we have 5 to the 7th times 5 squared times 5, which is a 5 to the 1st. And we just add all of these exponents. We have 7 5s, 2 5s, and 1 5. So altogether we have 10 fives.